started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be discussing exception handling in Python. But before we get into handling exceptions, we need to discuss what exceptions are. So what is an exception? Well, an exception is some sort of event that occurs during the program's execution that disrupts its normal flow. Typically, if these exceptions aren't handled correctly, it means that the program is going to terminate or crash. And this is probably something you've already experienced in this course while working on assignments, examples, and labs. So let's take a look at an example of a program that causes an exception, or at least has the potential to. In this example here, it's a simple program that's trying to compute the compound interest for a certain investment. The user provides the principal, which is the starting amount for the investment, the number of years it's going to be invested for, and the number of terms per year. Usually that's 12 or 1 per month. We do have a hard-coded value, which is the annual rate constant, and this is hard-coded the annual rate to 5.95%. Later in the code, we try to actually compute it using the formula for compound interest, and we print the result back to the user. Fairly straightforward, but there are some ways this code can cause an exception or an error. Let's take a look at one such example. So let's say the user is inputting their principal amount, and instead of inputting a valid integer or floating point value, they type in the text duck. Well, in our code, when we try to convert that into a floating point number using the float function, it's going to raise an exception. In this case, that's going to be a value error. And we get this trace back in the terminal that looks something like this. That gives us a hint about what the error was, but it also gives us the exception type. So in this case, the error or exception that happened was called value error. And along with that, it also gives us the error message, specifically what went wrong to cause this value error exception. In this case, it says could not convert string to float, and then it says what that string was, which was duck. So exceptions usually have two properties to them, at least two important ones: their type and the error message they contain. Let's take a look at another way this can raise an exception. So in this case, for the principal amount, the user puts in 10,000, and for the number of years, they input 10. Both of these are completely fine and valid values. The issue occurs in the next line, where they're asked for the number of times interest is compounded per year, and they input 0. This is a problem because 0 is stored in the variable n, and in our equation here for compound interest, we divide the annual rate by n. That's an issue because if we put in 0 for the number of times interest is compounded per year, then we're going to get a divide by 0 error. And indeed, if we input these values and run this in Python, we get a 0 division error exception. And the message in that exception would be float division by 0. Now there's a few ways we could deal with these error cases. We could take an approach like we saw previously in the course, where we add some if statements and logic to basically validate the user's input before we actually use it. For example, to convert it to another type, or use it in division. And we've done that in past videos, and that prevents these exceptions from ever being raised in the first place. However, there is a second approach we could take, and that would be dealing with or handling these exceptions after they occur. And that's what we're going to concentrate on in this video today. But before we do that, we need to know what exceptions are available and what exceptions can occur. On the screen right now, you can see a listing of some of the most common built-in exceptions in Python. For a full listing of all the different exception types that exist, you can see the link in the lower left corner of this slide, which will take you to the Python documentation on built-in exceptions. And you may notice this isn't a simple list, it's a tree diagram. That's because all of our exceptions exist in a hierarchy. In this hierarchy, as we get closer to the top, to that base exception, things become more general. That means the exceptions at the top cover more and more sub-exceptions, more and more things that could go wrong in your code. As we get to the bottom, to the leaf nodes in this hierarchy, then we get more and more specific. These become very, very specific things that could go wrong in your code. Depending on where we are in the hierarchy will be important, as we'll see later in this video, because we get more specific or more general in our exception handling. So one thing you'll notice is at the very top, we have the base exception. This is the exception that all other exceptions inherit from and covers all exceptions that can occur. Lower down, like these leaf nodes here, we have very specific exceptions that describe a very specific error that can occur in your code. For example, we have zero division error, which is like what we saw in that last example, as well as a value error, which would be, for example, trying to convert one type to another that isn't valid. We also have things that we've seen in the past, like index and key errors, which are errors that can happen when we go out of the range of a list, or we put in an invalid key into a dictionary that we're trying to look up a value for. We also have things like name errors. That would be if we try to use a variable that hasn't been defined yet. And we have things like type errors if we give the wrong type to something. We also have a class of different exceptions that fall under OS errors. These all inherit from the OS error exception. For example, we have file not found, which would be the error if we try to read from a file and it doesn't already exist. There's many exception types, and keeping in mind that they exist in this hierarchy will be important later on for what exception type that we're looking for when we're handling exceptions. Let's now move on to talking about how we handle exceptions in Python. And the way we do that in Python is with the try except block. The try except block catches and handles exceptions that occur in a specific block of code that's surrounded by the try clause. The goal is to allow the program to continue running even if an error occurs and allow us to handle that error in an intelligent way rather than just having the program crash or terminate. So let's take a look at the different elements of this block. So first we have the try block, and that contains code that might raise an exception. This is all the code that we're checking for an exception in. The except block contains the code that we're going to execute if an exception or an error does occur in that try block. Let's take a look at the syntax for the try except block now. And we can see that at the bottom of the screen here. First, we have the try keyword, and that's followed by any number of lines of indented code. All the code indented under try is the code that we're going to check for an exception. After that, we have any number of except statements, and these contain indented code that represent the code we're going to execute if that exception was raised. You'll notice that except takes an exception type. This is one of those exception types that we just saw in that hierarchy, and it is going to mean that this code is only going to be executed if this specific exception is given. For example, if we list file not found error, this code would only be executed if the code in the try block above it caused a file not found exception. If a different kind of exception, like a value error occurred, then this except block's code would not be executed. So it has to be specific for the given exception type. The other element here is the exception variable. This allows us to access and deal with this exception as an exception named exception var in this case, but we could use any variable name we like. For example, a common one is just to call it e. Once we have that variable, we can then access some details from the exception object, such as the message that was contained in that exception, which might help us processing that error. Let's take a look at some examples. In this example, we're going to try to improve that first example that we saw in this video, where we were computing the compound interest for a given principal, years, and number of terms per year. That was labeled as example 8.0a. And it had a few issues where it could cause different exceptions. So we are going to try to handle those with the try except block. We're going to start by handling that value error that could occur. And that value error could occur if the user put in something silly for a number, like duck or cat, instead of principal or number of years. So you can see we've surrounded basically all the old code with a try block. That's circled in blue right now. And what this does is it's going to check this code, and if an exception occurs in this code, it's then going to take a look at all of the different except clauses in this block. And if one of them matches the same exception type, it's going to run that code. So if a value error occurred anywhere in this block of code, then we're going to run the code listed down here under except value error. So this code will be executed if a value error occurs in the above block of code. And what it does is it simply outputs error, invalid input, and then exception message was, and then prints out the exception message. In this case, we're listing value error as the exception type, so this will only be executed if specifically a value error happens. If we got another error like the divide by zero error, then this block of code won't be executed, and since that isn't listed in our exception handling at all, that means the code will still terminate. However, if a value error does occur, we're going to run this block of code instead of terminating or crashing our program. You also notice that we list a variable name here called except. This could be named anything we want, but this stores a reference to the exception object. That's important because it allows us to access different parts of that exception. Here we're just sending it to the print command, which converts it to a string. When we convert it to a string, we get the message stored in that exception, which will be a short description of the error that occurs. Let's see an example of what happens when this is run. So when the user first executes this program, it's going to stop at asking them to input the principal amount. Let's say they put in something silly like the word pizza instead of an actual floating point value. This is going to cause a value error exception because we're directly trying to send that to the float function to convert it into a floating point number. The problem here is that pizza can't be converted to a float, so it's going to raise a value error exception. Before, when this occurred, it caused the program to crash and a traceback to be printed. But something different is going to happen now. Instead, when the value error occurs, we're going to jump into the except block and start running that code. This is going to result in a new message being printed out that's defined in this except block. In this case, it's going to print out error invalid input, then exception message was, and it's going to actually retrieve the exception message from the exception, which in this case is going to be could not convert string to float, and then it gives the string, which was pizza. So where this exception message is coming from is from that except variable that we had set in this except line. Remember, this doesn't have to be called except, we can call it whatever we want. Common one is to use just an E to represent an exception. And this is a reference to the exception object, and when we convert it to a string or use it in print, it outputs the exception message that was stored in the exception. So now let's look at another way this can raise a value error exception. So let's say the user ran the code and they already put in a valid principal amount and a valid number of years. But for the number of times interest is compounded per year, they put in 0.123. This is a problem because we then immediately take that string and pass it to the int function. And the int function can't convert 0.123 into an integer value, so it raises a value error. This causes execution of the program to jump to our except block and run the lines of code in there again. So this looks very similar to last time. We get error, invalid input, and the exception message was invalid literal for int with base 10, and then it says the string again. So it's important to note here that in those last two examples of running this program with invalid inputs, we never run the line future value equals or the print statement that contains the text the future value of the investment is. Because as soon as an exception is raised, we jump out and we go into the except block. If we don't handle that exception, then the exception propagates outwards through each function call until it eventually will terminate the program if it has never been caught by a try except block. So what happens if we do a divide by zero error? So this time the user inputs valid values, except for the number of times interest is compounded per year, they input a 0. Remember the last time we ran this code without the try except block, that caused a traceback and the program to crash. Well, in this case, it still causes the program to crash because we're not handling that exception. We're only handling the value error exception. So we still get a zero division error and the message printed out. And that's because we only handle a value error. And a zero division error is not a value error, so the except block never executes, and the exception propagates outwards until it causes the program to terminate. So it's important to note here that you always have to list every exception type that you want, or at least a generic exception type that includes all of those as its children. As I alluded to earlier, the try except block does allow us to handle multiple different exception types for the same block of code contained in a try block. The way it does this is it allows us to define multiple exception blocks, one for each specific type of exception that we wish to handle. This is great because it allows us to use different handling strategies depending on the exception type. In the example we see right now, we've updated the previous example to add a new except block. This one is responsible for handling zero division errors. So now if a zero division error is raised inside our try block, we'll execute this code. Now one thing you may have noticed is we omitted the exception variable here. That's completely allowed, but in this case we won't be able to access the exception message. So if you don't need to access the exception or the exception message, you are free to omit it. Either way is valid, but if you do need the exception message, you do have to have as and then a variable name so you can access that. So let's see what this code does. So when the user inputs 100 for the principal, 5 for number of years, both of those are valid. But now for the number of times interest is compounded per year, they input 0 again. Before, this would cause a zero division error to be raised. And that error is still raised by this line right here, which causes that divide by 0 error. But in this case, it doesn't propagate outward and cause the program to crash because we handle that exception specifically down here. So a zero division error exception is raised, and that is handled by this except block down here, which prints out the text, error, number of times interest is compounded cannot be 0. And we get that in the terminal. So now we're handling both types of exceptions, and what code we run in the event of that exception is based on the except blocks that follow the try block. Another way we can handle multiple exceptions for one try block is by using a more generic exception type. If you recall this hierarchy that we saw earlier, if we use an exception that's more generic or sort of higher in the hierarchy, ancestor of the other exceptions, for example, except here, then that's going to include all of the exceptions that are children of that exception. So if we just specified exception as our exception type, that would include everything below it, including zero division error, value errors, as well as other things like OS errors, name errors, everything below it, including index errors, key errors, all of that. So this would allow us to handle any of those exceptions that are classed under this exception. We could also be a little bit more specific and say specifically OS errors, and we capture all of those, including file not found. Or we could say arithmetic errors, and we would capture all those different types of arithmetic errors. And the way we can figure out which ones are covered are any that are children, which means that they are further down in this hierarchy here, as is shown by these red lines. So in this case, it's important to note that both value error and zero division error are descendants of the exception type. And we can see how that plays out when we try it in some code. So here's that code updated yet again, but instead of declaring both different exception blocks for each one, a value error and zero division error, we now just have one exception block, and it uses a more generic exception type. In this case, that is the exception, which both of the previous exceptions, value error and zero division error, both descend from. Because this is more generic, that means it's going to handle all of those children exceptions too. So if the user were to put in something like not a valid number as their principal amount, this block of code would be executed, but it would also be executed if they put in that 0 and we got that divide by 0 error to be raised. In either case, because both of those exceptions are children of the exception, that means that we run this block of code. Now I will point out that usually it's good practice to try to be as specific as possible. We should only catch an exception with an except block if we know how to handle that exception, or we were expecting it specifically, and there's something we could do about it. We don't want to just catch all exceptions and just print an error message to the terminal, because that could make it harder to debug our code, as well as important errors could go unnoticed. Now I should also mention that the order of our except blocks is very important. The first except block to match an exception will be executed. And this can be important when we have generic exceptions thrown in with more specific exception types. Let's take a look at two examples that clear this up a little bit. So the try block of both of these is the same, and in both cases it's going to raise a zero division error because we have a literal 0 hard-coded in there that's going to cause that error to be raised when we divide by 0. However, notice the except blocks are in the other order for each example. In the first example, we have a zero division error first and exception second. And in the second example, we have exception first and zero division error second. So in the first example, when we run this code, the zero division error exception is going to be raised in the try block, and the first exception block to match is going to be the zero division error block, and that's going to output zero division error. However, in the second example, when the zero division error exception is raised, we're going to execute the first exception block with the exception type. The reason why is exception is a generic type and zero division error is a descendant of that type. Because exception is generic and it includes the zero division error, that means that that first block is going to be run because it's going to match the zero division error exception. So in that case, we get other exceptions. And the second exception, zero division error, is never executed and never could be executed because it's only checked afterwards. This is very similar to the construct in if statements, where we have an if and then an else if, and that else if is only ever evaluated if the first one was false. The try except block does have a few optional blocks or clauses that we can add. And one of those optional clauses is the else block. And the else block is only executed when no exceptions are raised in the try block. So if everything went fine in that try block, no exceptions were raised, no errors occurred, then the else block is going to be executed. And this can help keep our code nice and clean and make it very clear about what should happen when the try block succeeds. Here we can see the syntax of the else block. It's been added on the end of this try block construct here, and we use the else keyword to identify it, just like an else in an if statement. And just like an else in an if statement, it's followed by one or more lines of indented code that are going to be executed if no exceptions occurred in the try block above. Let's now take a look at an example. And in this example, we add an else clause and a block of code under else in an attempt to handle a file. In this case specifically, we're looking for a file not found error exception from when we use the open function. When we use the open function on a file, in this case hello.txt, if that file doesn't exist or it's in the wrong directory, we will get a file not found error exception being raised. So this code is going to try to deal with that, and if no exception occurs, then we're going to output the file. So let's break it down. The first block here is the try block. This is going to contain all the code that we're checking an exception for. The second is our except block, and this is specifically for a file not found error. This occurs, we're going to output the text, could not find hello.txt, make sure it's in the same directory. And the last block is our else block. So if no exceptions occur in the try block, then we're going to run this code. This code simply goes through every line of the file, and it outputs that to the console, removing any extra line breaks with the strip method. Then it finally closes the file. Lastly, outside of the try except block, we have a print message, and it's just going to say all done. So it's important to note when we're done executing the code in the try block, we do resume right after the try block, just like we do with a loop or an if statement. So this print statement with all done should be executed regardless of what happens in that try block, so long as the exception is always a file not found error exception. If it's a different type of exception, that's not going to be handled by this try block, and it will cause the program to crash first. In this case, we're going to try running this program on the file hello.txt that's displayed here. It just has a few simple lines. It's the same file we used in a previous video. So let's say we run it and the file doesn't exist. In this case, we're going to get the text, could not find hello.txt, make sure it's in the same directory. And then we get all done. So what happened here is the open function raised an exception. That exception was handled by the file not found error exception block that outputted the code, could not find hello.txt. And then when that block was done executing, we resume from outside the try block. So in this case, outside of that try except block was a print line that said all done. So we printed that and we completed the program. Now let's take a look at what we would get if the file did exist. So in this case, the file exists. So the try block code finishes normally. No exceptions occurred. So then we continue in the else block. The else block has a loop that prints out the contents of the file, which we see in the terminal. And once this else loop is done and the file is closed, we then jump down and we print out all done. Now you may be wondering, why have this in the else block? Why not just put this code at the end? Well, if we did that, our code would likely raise a new exception because file wasn't opened correctly and the program would crash. By having it in the else block, we guarantee that that file has been opened and didn't raise any exceptions. So that else block is only executed if the file was opened correctly. So this prevents further errors, and it also makes it so our output is nice. We don't get any tracebacks in the event that the file doesn't exist. Now, else isn't the only additional clause or block that we can add to the try except block. It also takes an optional finally block. And the finally block guarantees that whatever code is in the finally block is going to be executed regardless of whether an exception was raised or not. It's ideal for any cleanup activities, especially when we're working with files, so we can ensure that a file is always closed or other resources are cleaned up. So here is the syntax for the finally block. It's probably what you expect. We just add a finally clause at the end here, and any of the code indented in the finally block, one or more lines, will always be executed if an exception occurs or if an exception doesn't occur. That way we could do something like close a file to make sure that we have handled it correctly, regardless of an error occurred or not. So let's take a look at a more complex example now. And in this complex example, we're going to have a program that tries to open a CSV file. Remember, that's a comma-separated value file where each value is separated by a comma. And it's going to contain some information about a user of the system. Specifically, it's going to contain their username, age, and account balance. Here's an example of what the file might look like. So here we have a username, which is 0cool. We have their age, which is 18. And then we have an account balance, which is a floating point value. We're going to want to write this with some exception handling that's going to handle a number of different cases. And we want to use that finally block that we just saw to ensure the file is always closed before the program terminates. So I have the code for this solution up here, but we're going to go take a look at it in PyCharm to get a better idea of how it works. Let's switch over there now. Okay, we're in PyCharm now, and I have example 8.2 opened up, and we also have a few different files to test it with. The first file is that example we saw in the slides, which is a valid file. The second file is one that is not valid because it has no age given, rather than an age here. The next one is missing some data. They don't have their account balance. And this one has an invalid age. It has a decimal number where the ages have to be integer values. So let's take a look at the code. So we can quickly look over it, and we see that we're getting some input here. We're inputting the name of a CSV file. We are setting up a file as none. Remember, none's a keyword we can use just to say that this doesn't have a value yet. We have a try block where we're trying to open and process the file. And then we have a few different except blocks that are handling different errors that could occur. And then we have a finally block that deals with closing the file. And lastly, we have a print statement outside of everything that's just going to say all done. So let's take a look at this try block. So here we are opening the file in read mode. We get a file object and we store that in file. And then we read the first line of the file. There should only be one line. And then we try to clean the line with strip to remove the extra line break. We then split it at the commas. So this will create a list of each value. So we'd have a list with 0cool and one element, then 18, and then we would have their account balance. Next, we try to store those different values in variables, as well as convert them into the correct type. And then we print out the final result here. So there are a couple of different exceptions that could happen in here. And those exceptions are file not found error, value error, and index error. So what I'm going to do is put up a timer, and I'd like you to think up of different inputs for this program that would cause each one of these possible exceptions. So try to think up of one input that's going to cause a file not found error, one that's going to cause a value error, and one that's going to cause an index error. After you're done, we'll take it up.
Lines of code on screen again. Python's flowing through my pen. Hourglass is running out. Gotta solve this right, no doubt. Deadlines looming, it's so tight. Tick-tock goes the clock at night. Functions, loops, and ifs and elses. Each line fixes all my messes. Coding fast, time is slipping. Got no pause, pressure's gripping. Python rhythm, keep on beating. Countdown timers, never cheating. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day.
And we're back. Let's try running the program now in debug mode and seeing if we can cause each possible exception. So I'm going to put a breakpoint right here, and we'll run the code. And we're running in debug mode. So first we want to try running this the correct way. So we'll put user.csv, which was our valid file, and we'll run through each one. So we're entering the try block now. We're going to open the file. In this case, the file was valid. It does exist, so it opened fine. And we are reading the first line of the file. We can see we've read in the first line of the file here. We have 0 cool, 18, and their account balance. We're now going to split that into a list of data. The split worked correctly. We have 0 cool, 18, and their account balance. And now we're going to split that into different variables. We get their name and name. We get their age and age as an integer. And we get their balance and balance as a floating point value. And then we print that result to the console. So 0 cool is 18 years old and has $1,337.42 in their account. We can then enter the finally block. So even though no exception occurred in this run, we jump down to the finally block, and we're going to print closing a file. We're going to check if the file is not none. If the file is not none, it means that it was opened correctly and we need to close it. So we run close, and then we print closed, and then we finally get out of this try except block, and we continue on with the program at the next line, which is going to print out all done. So let's see how we can cause one of those errors now. And the first way is simply going to be inputting a file that doesn't exist. So I'll just put up some gibberish. And we can see that we've paused right here at the breakpoint, and let's go down. So we enter the try block. Now we're going to try opening the file, but we put in some gibberish as the file name. So this should cause an exception. And it does. So this caused a file not found error. And we jump from there down to this except block because this is the first except block that matches the exception type, file not found error. You can see that we have a error variable, which is a reference to the exception object. We output to the console, error invalid file name, and then we output the exception message. So what happened there is error was converted into a string, and it was output to the terminal, which said error 2, no such file or directory, and it gave our file name again. Now, even though an exception occurred and it was handled in this block, we then jumped down here into the finally block, because finally is always run whether there's an exception or if it runs fine. And we start closing the file. In this case, there was no file, so we don't close it, but we do print out closed. And we then eventually get out of the try except block and print out all done. So the first way we could trigger one is through having an invalid file name. So we're going to run it normally now and try to trigger the other exceptions. So in this case, we're going to try giving it this bad data where we have no age given. So this is going to cause an issue because we're trying to convert that to an integer. So let's see what happens. And you can see what happened here is we got to this line of the code. It tried to convert the line that was no age given into an integer value, and this caused a value error, which caused us to jump down here and output the error message and the text that file contained an invalid value. In this case, the error message was invalid literal for int with base 10, and it was no age given. The other way we could cause an exception to occur would be an index error. And that could occur if we didn't actually have enough columns in that file. And that occurs in this one here. It'll be bad user file 2.csv. And the issue here is it doesn't have one of the columns, which is the account balance. This causes an error here because we're trying to access an element in the list that doesn't exist. This causes an index error exception and it causes our code to jump down to this except block. And we get the message, the file is missing an expected value, and the error message is list index out of range because there was nothing at index 2. So we have 3 different errors that we cover here, and in all cases, we always close the file. There is one more bad file we can try, and this one has an invalid age because it's not an integer value. This one's going to give a very similar result to what we saw before when we had a string instead of their age. And again, we get the same value error, which causes it to jump from here, where it tries to convert it, to our value error code, and we output the file contained an invalid value, which we do right here, and we output the message, showing that 19.5 is an invalid integer. So let's switch back to the slides and learn a little bit more about this finally block. And we're back. And in your slides, you can find a copy of those same outputs that we saw in PyCharm for your reference. Now, the last thing we should mention about the finally block is that it does always run, even in some pretty extreme circumstances. So if there is an exit call inside the try block, it will still run the code in the finally block before the program terminates. If you remember, the exit function causes a program to immediately terminate and not run code after it. Also, if this try except block exists inside of a function and you have a return call inside that try block, the finally code will still also execute. This is great because if we use it for something like closing a file, especially when we're writing to a file, it means that it's always going to close that file properly because it is always executed, even if we do something extreme like exit the whole program. So here are a few examples. And in all of these cases, the output is actually the same. It's going to say in try and then in finally. In the first example, the leftmost example, we have a call to exit in the try block. And even though exit is called, it still causes the finally block to execute. It's going to print out in finally, and then it's going to exit the program. So the last line, this line will not run, isn't executed because it's outside of the finally block, but the code in the finally block does run even though exit was called. And in the middle example, we have the same sort of setup, except we're in a function now. And instead of exit, we're using return. So even if we're returning from a function, the finally block is still going to be executed. It's going to output in finally, and we would, in this case, not get the text. This line will not be run because we return from the function before that line is executed. In the last example, the rightmost one, in this case, we are in a while loop, and instead of a return or exit, we have a break, which causes the while loop to terminate. So in this case, finally again is going to be run, and we get in finally output, but we don't get the last line. This line will not run because that's contained in the loop, and we break out of the loop before we get there. So the difference between having code outside of a try except block and code in a finally block is that we have a guarantee that the code in the finally block will execute even in these extreme cases, whereas code that's just outside of the try except block may not be executed if something happens in that code that causes the program to terminate or jump to some other part of the program. Just like blocks of code used in loops and if statements can contain other loops and if statements, blocks of code contained in try blocks or except blocks can have other try except blocks nested inside of them. This can be useful because it allows us to use specific exception handling techniques in inner blocks and general exception handling techniques in outer blocks to make sure we cover all the areas and handle specific exceptions in the ways that are appropriate for those exception types. Here's an example. In this example, we have a dictionary with a certain amount of employees in them. Each key for the dictionary is an employee ID number. For example, 101 is for Alice, 102 is for Bob, and so on. The values in the dictionary are going to be the employees' names. So this dictionary can allow us to look up different employee names by their employee ID. But if you remember from our dictionaries video, there are a few ways that a dictionary can raise an exception. And one of those is trying to access a key that doesn't exist in the dictionary. So in this case, we have wrapped our code to deal with this dictionary in two different try blocks. The first try block, or the outer one, is checking for value errors. And it's going to handle any value errors raised inside of this try block, including the other try block that's nested inside of it. The other try block we have is for the second line where we're accessing a specific element of this dictionary at a specific key. In this case, if a key error happens, the key isn't in the dictionary, we are going to handle that in this inner try block where it has an except key error that's going to print out a message. So if we were to run this, and we were to give it the input rubber duck for employee, this will cause a value error because we can't convert rubber duck to an integer value. So this line would cause the error, and it would jump to the outer try block, and it would go to this except block, which says, error, please enter a valid integer ID. Now, the other way we could get an exception is if we put in a valid integer, but it doesn't exist in the dictionary. In this case, they input 999, which isn't one of our employee IDs in the dictionary. This causes a key error to occur, and it's raised on the highlighted line here. But because we're in the inner try block, this is handled by this except block here, which says error, employee ID not found. So the inner block is always going to be checked first. If it has a matching exception type, that's going to be run, and then the outer block is checked. So one thing we haven't covered yet is how we can recover from an exception. So far, in all the examples we've seen, when an exception happens, we just output to the user some nicer text saying it happened, and then we let the program terminate. But we can handle exceptions in a more intelligent way, especially when we combine them with loops. For example, asking the user to input valid input again, because maybe they just made a typo and they don't really want to exit the program. Let's take a look at an example. And in this example, we're trying to input a floating point value from the user. And instead of just exiting and printing an error when it's invalid, we want to keep looping and asking for that floating point value until they input a valid one. Now, previously in the course, we saw examples like this where we were using an if statement to try to evaluate if it was a valid floating point value. But the logic for that could be a bit of a pain. We'd have to check if there's only exactly one decimal point and everything else was a number and so on. So what we could also do is try to convert it. And if there is a value error, then we're going to handle that value error with the try except block and then restart the loop until they actually input a valid value. And the key to this is having the break statement inside the try block. So this break statement is only going to be executed if the line before it does not raise an exception. Because if it does raise an exception, it's going to jump to that except block and the break will never be executed. Remember, the break statement exits the loop and would finally allow us to finish the program. Here we can see an example output for some inputs by the user. In this case, the user first inputs the word duck, which is not a floating point value. This causes a value error to occur, and that's handled by the except block, which simply outputs invalid input, try again. Now, because this is in a while loop, the loop restarts, and it asks the user for input again. This time, they input 1.2.3, which is not a valid floating point number, so again, a value error is triggered, and the loop restarts. The last time, the user finally puts in valid input of 1.23, and this is valid, so no value error is raised. This means the code can finally advance to the break statement and then exit this while loop. The only line outside the while loop is a print line outputting the value, so that's our last line of the output. So using this sort of construct allows us to keep asking the user for input until it's finally valid. And we can use the same sort of construct for other things like reading from files, as well as anything else that has an error that could be corrected by doing it again or asking the user for input again. Next, we're going to talk a little bit about handling file errors. And so far, we've seen a few exceptions that are related to files, but now we're going to go over some of the most common I/O exceptions that relate to files. And the first one, and we've seen this a few times now, is file not found error. This exception is raised when there's an attempt to open a file that doesn't exist, or maybe we're looking for it in the incorrect directory. Next is permission error. We haven't seen an example of this yet, but it can occur when the program tries to read or write to a file that it doesn't have the necessary permissions to access. Next is unsupported operation. And note that this has IO dot in front of it because this comes from the IO module. It's not in the global space. This occurs when a file is opened in a mode that doesn't support reading or writing. For example, if we open a file in read mode and we try to use write on that file, we would get an unsupported operation exception. Next is file exist error. And this is sort of the opposite of file not found error. This is when we're trying to create a new file or a directory, and that file already exists, and whatever mode we're using doesn't support overwriting. There are some modes that will write to a file, but they will never overwrite it. If that file already exists, they'll raise a file exists error. The next exception type I'll mention is OS error. And this is the base exception for many of the IO exceptions I've mentioned so far. If you recall from earlier in the video, I mentioned that all exceptions live in this exception hierarchy that we showed on the screen. OS error would be the ancestor to many of these exception types, and they would be the descendant of the OS error. That means we can use OS error as sort of a generic exception that captures many of these, but typically it is better to be more specific in your exception types. In the previous examples we've seen so far that deal with files, we've always had to have sort of like a finally clause to make sure that the file is closed properly and any resources are cleaned up. This is quite a common task when you're dealing with files to need to close the file. So instead of having to write out the whole try except block with a finally statement, Python has a bit of a shorthand for this. And that comes in the form of the with statement. The with statement basically allows us to simplify handling files, and it's going to ensure that the file is always closed for us, regardless of an exception occurs, we try to return in the with statement, or anything else. So it basically ensures the file is closed, and we don't have to manually handle that. And here we have the syntax for the with statement. This always starts with the keyword with, and then we have the way we're opening the file, which is the open function. So in this case, we're telling it to open the file file.txt, and the mode that we're giving it is read. This could be any file name in any access mode. They'll all work with the with statement, so it could be reading or writing. Then we have the keyword as, and then a variable that we're going to use to keep track of the file object. In the other examples we've seen in this course so far, we had file equals and then the open function. So this is sort of the same thing, where file is going to be that reference to that file object. They'll allow us to do things like read from the file, using like the read lines method. Inside the with statement, there's going to be a block of one or more lines, and they're all going to be indented in that statement. Whatever happens in this, regardless if there's an exception thrown, we return, we call the exit function, anything like that, with is going to ensure that this file is closed after this block of code is finished executing. So whatever's in this block of code, once it's done, it's going to ensure that the file is closed, just like if we wrap this in a try block and we had a finally statement that said file.close in it. Now we can use exceptions with a with statement. With is just going to ensure the file is closed. It's not going to do any special exception handling for us. And there's two ways we can do this. We can either encompass the with statement and the block of code within it inside of a try block. That means we wrap it in a try block. Or we can put the try except block inside the with statement. Let's take a look at some examples of both ways. So in this first example, we're wrapping the whole with statement and the block it contains inside of a try block. So this try block is going to apply to all of the code inside of the with statement, including the with header itself. So for any reason a file not found error is raised inside that code, or even in the open command, then it's going to execute the except block, which will print out file not found. And because we're using with here, we don't have to close the file manually. It's going to handle that whether there's an exception or not. So we will only have to worry about other exceptions like file not found error. We don't have to worry about adding a finally clause. The next example includes both methods. So on the outside, we have a try except block, just like we saw before, that's still handling that file not found error. But now we also have an inner try except block that's inside the with statement. And what this is going to do is going to handle errors when we can't convert the contents of the file into an integer. So if this file contains anything that isn't just an integer value, it's going to cause a value error, and that's going to be handled inside in the inner try statement. So it's important to note here when we have nested try statements like this, that the innermost one is going to be evaluated first. So if for some reason we are checking the same exception type inside and outside, like instead on the outside if we had another value error instead of a file not found error, the innermost except block would be executed and not the outermost one. In this case, they're handling two different errors, so there isn't any overlap. In the last example here, we show using this in a function. So we define a function here called readFile. It takes a file name. It tries to open that file with the with statement in read mode. It tries to read all of the data from that file and then return all that data. If the file is not found, then it prints out error, file not found, and then it returns none. Now, an interesting part of this code segment is calling return inside of the with statement. Now you might wonder if that's going to be an issue, because we should ensure that the file is closed first. Well, the with statement is going to ensure that file is closed, even if we return in the with statement. This is also true with other ways of exiting the program, such as calling the exit function. With is still going to make sure the file is closed before the program terminates. It's just like that finally block that we saw earlier in the video, which is always executed. The last thing we're going to discuss in this video are some general tips and best practices for handling exceptions in Python. And the first tip is to be specific as possible with your exception types. When you're providing an exception type in an accept block, you want to use the most specific exception type that you can. We want to avoid using general or base exception types like just exception to try to catch all exceptions. This can make your code a lot harder to debug, and it can also mask some errors that are happening in your code if you're not doing anything with those exceptions. So try to be as specific as possible, unless you have a good reason to be more generic. The next tip is to avoid the bare except clause. And by bare except clause, I mean using except in a try except block, but not providing any exception type. This is allowed, but it does mean that it's going to catch all exceptions, regardless of their type. And this is the same sort of issue as in the last tip, where it's going to make debugging far more difficult, and it's going to hide unexpected errors that you might not actually be handling correctly. The next tip is to use the finally clause or the with statement to clean up resources after you're done. A big one would be closing files or network connections if you're being a bit more advanced, and making sure everything is properly released. Next is do not suppress exceptions silently. We really want to avoid except blocks that don't actually do anything, like just have a pass statement in them. You should always handle the exception in some way. At a very minimum, you should log it by either putting it out to the user or recording it in some file. You never want to have an exception and just ignore it, because it means there's probably something wrong in that code. And lastly, we want to keep exception handling code concise. We don't want to wrap our whole code in one single try block. We want the try blocks to be as short as possible and only include code that you think is going to raise an exception. So we want small try blocks and not massive ones. It's fine to add more try except statements to cover other exceptions. So that's all I have for you in this video. Our next video will be on raising your own exceptions and setting your own exception messages. So make sure to check that out if you're interested. Thank you for watching and have a great day.